Hey guys, welcome to question FM394 of the Further Maths Fortify study guide. So this question reads, grade 2 schoolboys Tommy and Jacob have long contested over who the fastest runner is of the two. It is decided that they will race. The first boy to run to the tree 100 meters away and then back to their starting position will be crowned fastest in all the schoolyard. Tommy reaches the tree after 20 seconds and finishes the race in 40 seconds. The graph below shows his distance d from his starting position in meters t seconds after the race begins. So we've got distance and time there. We've got a graph that looks much like this one. Question A asks us, what distance will Tommy have run after 25 seconds? So to delve a little bit into this graph here, it would appear that Tommy runs away from his starting position towards the tree, which is 100 meters away. So at this point up here, that's where Tommy reaches the tree after 20 seconds. And then it takes him another 20 seconds to run all the way back, completing his race in 40 seconds. So at 25 seconds, reading the graph, what we can see is we've traveled 100 meters in the first 20 seconds. And in the next 5 seconds on the way back, you'll notice that at 25 seconds, that coincides with the point here, 75. So the coordinate here is 25, 75, which means that if we subtract the 75 from the 100, we actually should get another 25 meters that he's covered on his way back. So all up, after 25 seconds, Tommy has run 125 meters. Alrighty, part 2 or part B. Actually, before we get part B, we're given a little bit more information. We're told, let A be Tommy's distance from his starting position in meters t minutes after the race starts. The linear relation that represents his run to the tree is of the form A equals k times t, where 0 is less than or equal to t, which is less than or equal to 20. So this formula only counts for the first 20 seconds of Tommy's race. The slope of the line k is the speed at which Tommy is running in meters per second. Show that k is equal to 5. So this we can do because we just have to substitute two values for a and t in order to solve for k. So a pretty easy point for us to look at would be this one here, which is the point 20, 100. Substituting these values into our equation here, what we should get is that 100 is equal to k times 20. And by rearranging or solving this equation, we end up with 5 is equal to k by dividing by 20 on both sides. And this here should be showing that k is equal to 5. Part C. Well, actually, we're getting a little bit more information once again. Below is the relation that describes Jacob's run, where B is his distance from his starting position in meters t seconds after the race begins. M is the time it took Jacob to reach the tree, and N is the time it took Jacob to finish the race. And so we're actually talking about this one up here. I might even just box it in for referral. So we're given B is equal to 20 times t over 3, where t is between 0 and however long it took him to reach the tree. So m here is the number of seconds it will take him to reach the tree. And then negative 10 times t over 3 plus 150 for all the values between m and n. So m being where Jacob reaches the tree, and n being where Jacob finishes the race. So then the graph below again shows the relation representing Tommy's run. So we've got another graph that looks like this one. And part C wants us to do a sketch. So part C says, sketch the relation representing Jacob's run on the axes below. Now, this one is maybe a little bit more tricky because we don't know these values of m and n. We don't know how long it takes Jacob to run to the tree or how long it takes him to get back and finish the race. To figure this out, we're going to need to take some of the information that we already do know. What we do know is that the tree is 100 meters away, which means that we should be able to find this value of t if we substitute the value of b for 100. So if we say that 20 times t over 3 should be equal to 100 meters, and then we solve this for t, we should get t is equal to 15. So you can plug that into your calculator or you can do it manually, but you'll find that t is equal to 15. So at the 15-second mark, Jacob reaches the tree. So he's actually gotten to the tree 5 seconds before Tommy got to the tree. To find our other point, we want to know when he's back at his starting position, which means the distance from the starting position is going to be 0, and we're going to use our negative equation because this one is the one that involves where he finishes the race. So now we're going to solve negative 10t over 3 plus 150, where the distance will be equal to 0. Of course, we want to find t again. Plugging that all into a calculator, we should get that t is equal to 45 out here, meaning that we're actually going to pass like this. Whoop. Excuse my shoddy line there, but you get the idea. And then we're coming back. So to quickly summarize here, so this point here, first of all, is going to be 15, 100. And this point down here is going to be 45, 0. So quickly reading from this, what we can see is that Jacob reaches the tree first. In fact, he beats Tommy by a whole 5 seconds, but then Tommy actually beats him back by a whole 5 seconds. So it looks like Jacob's gotten pretty tired on the way there. Didn't conserve enough energy. That's part C. Part D, the final part, says how many seconds after the start of the race did Tommy catch up to Jacob? So there's 2 points that might have your attention. That'd be this point here and this point here, because we can see at both of these points, Jacob and Tommy should be the same distance from their starting position. However, only one of these is correct. The way we figure that out is that, first of all, if we look at this point here, what you might notice is that Jacob is actually beginning his run backwards. So he's already coming back from the tree at this stage, while Tommy is still on his way to the tree. So Tommy hasn't actually caught up to Jacob here. He's still well behind him. In fact, he's still going to make it to the tree and start running back before he can catch up to him, which is exactly what he does here, because he's run to the tree now, and now he is also running back. They are both running back towards the tree, and we meet here. And if we find where that point is in terms of how long the race has been going for, we see that it lines up with this 30-second mark here. So after how many seconds? 30 seconds. If you guys have any questions about this, please drop them in the comment section below. Otherwise, I will see you in the next video.